Okay, good evening, everyone. Welcome to join this data engineering panel discussion. So my name is Shawa. I'm going to facilitate this panel discussion today. We have two speakers, Pratika and Bhargavi. I'll let them do self-introduction later. But just before we get started, I'm going to go through a few slides to introduce data engineering, what the job market look like, and help you define data engineering a little bit. And yeah, just to set the tone. And if you have any questions regarding data engineering, how to become a data engineer, what are some of the things you need to learn, feel free to send the questions to Zoom. We will have plenty of time at the end for questions. So if you can save your questions to the end. You can feel free to unmute and ask them. Okay. All right, so let's get started. So first of all, WeCloudData is the sponsor of this meetup event. We are the organizer of Toronto Data Science and AI meetup, but we recently expanded to different cities as well. So you might be joining from a different city. Just so you know, WeCloudData is a data science and AI training academy, and we run a few interesting programs. So I'm going to just do a very brief introduction. So we have data science diploma program. This is a full-time immersive boot camp. If you would like to learn, Python, SQL, machine learning, and big data. We also offer real company projects for the students to add experience to their resume. We have business intelligence and data analytics program. Earlier this year, in February, we launched the very first data engineering, diploma program, and we're quite excited about the program. It's a pretty challenging one, but students get to learn a lot of the modern data engineering tools and skills. They're still doing their final capstone project right now, the February cohort. So if you want to learn data engineering, become more practical and get assistance, in getting a job, you can go to WeCloudData website and find out the details. We're also launching DevOps engineering program and AI engineering program later this year. All right, let's talk about data engineers. The data engineering, I think, as a career or as a profession is definitely on the rise. In terms of, if you look at the Google trend, the amount of search for data scientists is still higher, but the trend for data engineers is really good. And right now, if you search on Indeed or on LinkedIn for data engineering jobs, sometimes you'll find more data engineering jobs than data scientist jobs. That's very interesting because I think there are a lot of data professionals working in large and small organizations. And traditionally, some of these folks, experts are not really called data engineers. Maybe there's ETL specialists. They work on data ingestion or sometimes they get called big data developers. Just like, data analytics in general, data scientist wasn't really a very popular title maybe 10 years ago, but I think maybe 5-6 years ago, it started to become really popular. So yeah, it's relatively new, I guess, but data engineers are playing a very important and essential role for any kind of data organizations. Companies start to realize that if you only have data scientists, you can't really make magic happen because data quality is important. Data needs to be prepared. Your data pipelines need to be automated, right? So otherwise, it will be garbage in and garbage out. Data scientist was originally branded as the unicorn, but even if you can find unicorns, it probably still makes sense for a data science team or a data team to have different experts focusing on different areas, and they collaborate in one team to help push forward, right? So yeah, but there are different types of data engineers, I listed four of them here, but obviously it can get more specialized. But there's the traditional ETL, ELT engineers who focus on data transformation, integration. There's some data engineering or companies that that have a stronger software engineering culture. So they'd like to hire software engineers, but data savvy software engineers. So yeah, so I guess programming software engineering skills are more also very important if you would like to get into this kind of companies. There are, of course, the BI developers, and sometimes they work as data engineers as well. And I found that in some other startups, ML engineers and data engineers, sometimes there's a big overlap, right, in terms of the responsibilities. They both use maybe Apache Airflow to automate ML pipelines, work on the data quality check. So yeah, but I think the title doesn't really matter. When you're searching for jobs, what interests you should be the scope of the work and how much you can learn, maybe. And of course, salary is also an important factor. So, but yeah, there are different types of the job titles. There are many different job titles: ETL developers, SQL developers, big data developer, sometimes platform engineer that work with data architect, data warehouse specialist, or BI specialist. But I think overall, this type of roles are getting more and more popular. We also start to see the convergence of engineering disciplines. I think, in terms of the skills and tools, data engineers and data scientists and software engineer, or sometimes even DevOps engineers, there's some overlaps, right? For example, data engineering seems to overlap with all three different roles. On the data science side, data engineers also need to know Python, PySpark, and need to be really, really strong in SQL, know how to retrieve data, right? Do data transformations, preparations. And on the DevOps side, data engineers sometimes need to know Docker, Kubernetes, right? They are probably not the person who's responsible for maintaining or setting up the infrastructure, but or platforms, but they at least need to know how to work with Kubernetes. Maybe they're running Apache Airflow, DAGs, and workflows on a Kubernetes cluster. And certainly understanding Docker is beneficial because we start to see some companies using containerizing each step of their data engineering effort as well. So that's very interesting. And on the software engineering side, I think data engineers need to be strong coders for sure, understand version control, know how to unit test their data pipelines, their functions, right? So there's a little bit software engineering involved as well. All right. In terms of the job market, I think working as a data engineer could be pretty cool. It's not as, I think, maybe glamorous as data science, but, because data engineers most of the time are, behind, it's just like supporting in a more supporting role, right? Supporting data science teams, providing data. They work on ETL, but I think most importantly, data engineers will make everyone's life, in the data team, everyone's life a lot better, a lot easier. But there are a few factors when it comes to job satisfaction. It has great demand, and the salary is, also pretty. Compensation is very competitive in the job market. I'll share some numbers. It's a great way to learn new things. If you like to learn new things, you like challenges and problem solving. I think data engineering is the right field because you need to know a lot of different tools, and it keeps evolving, right? So the things we teach 5 years ago is already very different from what we teach today. We used to teach Apache Pig, had focus on Hadoop and Hive, but there are actually more advanced or better tools like Apache Spark or maybe Apache Flink, Snowflake. So you need to keep learning. If you have aptitude for that, I think this could be a very interesting career. And data engineers are making big impact. Maybe you're not the one who's presenting to a senior vice president, right, working directly with the business and getting all the credit, but having a very sound data engineering system, making sure data pipelines are all making sense, that is a huge impact, right, on the bottom line of the business. And you help eliminate a lot of repetitive work, make everyone else's work less painful and more productive. So as a data engineers, you might be helping the data scientists to optimize their Spark jobs, and so reduce the runtime from 5 hours down to maybe 20 minutes. That is actually a big achievement. And of course, I think data and the data field in AI is definitely growing really fast. Data is the new oil. So, um, I think, this is a career that you should seriously look into because it can potentially evolve into some other roles as well, as long as this field it keeps improving. So I'm going to share some numbers, so things we learned about data engineer jobs in North America. So there are some stats, from the Canadian job market, and there's some stats we collected from the US job market. So I think we did some web scraping from Indeed and LinkedIn, I think in a winter, but that was like 6 months ago. So at that point, we found that there are more data engineer jobs than data analysts and data scientists. But of course, it's kind of seasonal. So if you search now, there might be more data scientist jobs. But overall, I think data engineering, data analytics, data science, there are a lot of demand for sure, and it's just only going to increase over time. In Canada, Ontario or maybe Toronto, our Waterloo region hire a lot of data engineers, followed by BC and Quebec. So yeah, the major cities are Toronto, Vancouver, and Montreal, which makes sense because they're more population. It's more densely populated. There are more jobs. This is the distribution in the US market. As you can see, data analyst, there are more data scientists in demand in the US, but data engineering is trending pretty well as well. Some of the cities or states, California, New York, yeah, and these are just to break down by cities, but this will change over time. This is just a snapshot. In terms of salary, these are just base salaries, right? Not the total compensation package. In Canada, for a junior data engineer, the salary will range. I think the midpoint here average is about the blue line here is 85,000 for data engineers. The title will be junior data engineer or just data engineer. On the low end, 55,000. On the high end, 120. I think the number is pretty good. It's from Glassdoor. And as you can see on the high end, data engineers sometimes get paid higher than data scientist and very close to software engineer. That's junior roles. And in terms of senior role, it's very interesting. Senior data scientists get paid a little bit higher, relatively higher on the high end. And but senior data engineers also get paid a lot. The medium average salary is a little bit higher than even the data science jobs. So that's the number in Canada. And in the US, we found a big gap between data engineer and data scientist. And just for some reason, senior data engineers paid a lot higher than data scientists. I think that's probably because a lot of in the US there are a lot of data engineers that are coming from software engineering background. So these are the data savvy software engineers who work as data engineers. That's just my assumption here. But definitely you can see that composition wise, it's pretty rewarding. So you can do your own research. There are a lot of stats you can find online as well. In terms of this hard skills, technical skills, we found that on the right-hand side, you see this bar graph, Python, SQL. So I think for any type of data jobs, Python and SQL are important. That's because working as a data engineer, you not only need to know the scripting language, right? Python is like the glue, but SQL is very important because you're going to interact with many different kind of databases, not just relational database. I think if you work with Apache Spark, Spark supports has Spark SQL API and Apache Hive. Tools like Snowflake and BigQuery, they all SQL based. Even though the computation engine might be different, Spark and Hive are more MapReduce based. But again, SQL is something you absolutely need to know. And you'll notice that for data engineering jobs, big data and cloud is also important. So Spark and Hadoop, AWS. But in terms of the cloud platforms, it really depends on the companies you're going to join, right? AWS has a relatively larger market share, but if the company uses GCP, then you need to use GCP. But of course, it doesn't mean that you have to get AWS certified in order to get a data engineering job. And there are questions about, which one should I pick? I think it doesn't really matter. If you go into financial, institution, maybe using Azure if you're in Canada, because I heard a lot of banks in Canada use Azure, or maybe the government. But for retailers, a lot of them actually use GCP, right? But if you know AWS, you can definitely, get a job, from a company that use GCP, because, these are transferable. If you know AWS, it's not that hard to pick up GCP. Yeah, and of course, data engineering not only work on batch processing, right? You need to know Apache Kafka in some cases, if the company, ingest data using this kind of distributed messaging bus, messaging queues. Yeah, and a lot of big companies still use, Hadoop and Hive, right? So as you can see, data engineers need to know many different tools. But, one small suggestion that I have is when you start to learn data engineering, you may get overwhelmed because there are so many different tools you need to learn. So the suggestion is you just need to know a decent amount of tools and technologies. The most important thing is you need to know how to put them together, right? Work on projects, build end-to-end data pipelines, because you don't learn these separately. You have to put them to work together. That's very important, okay? Okay, I think that's it. That's my very quick introduction to data engineering. And we have experts today who can answer, more detailed questions regarding the career, the things you can learn. So let's get started. Let's move on to the panel discussion. So I'd like to welcome Pritika and Bhargavi. They are both data engineers, and they both come from software background as well. So I'll let them introduce themselves. Pritika right now works for Google Canada, and Bhargavi is working for Critical Mass. So Pritika, you want to go ahead and introduce yourself first?
Yep. Hey, everyone. Thanks for joining. My name is Pritika. I work as a data engineer at Google. Yeah, I've been working with Google for the last 3 years. Before that, I was working in an ad tech company in Canada. So I've been in this space for a while and happy to answer any questions that you might have.
Thank you, Pritika. How about you, Bhargavi?
Yeah, hi, everyone. So my name is Bhargavi, and I am working as a data engineer in the Critical Mass. I have been fortunate enough to work as a data analyst, data scientist, and on the data engineer part as well. And I'm happy to be a part of the panel here, and I'm happy to answer any questions you guys have.
Great, thanks. So we have, I think, 7 to 8 prepared questions. After those questions, we'll move on to the AMA session, okay? By the way, keep sending your questions to Zoom chat. I will, take notes so that, so to make sure that we can get those questions addressed at the end. So first question, Pritika, Bhargavi, can you tell us a little bit about yourself and how you got into data engineering?
Okay, I can go first. So I started I actually got into it by chance, I think, just because there were some teams in my office who were doing such work. And I think Shao had mentioned earlier that there wasn't really a title for it as such. So it was just like it was part of software engineering work. So yeah, it was by accident and I started liking it. And there was a lot of growth in the industry also and the kind of technologies that were being built around that. So I got hooked to it and yeah, now I'm here.
Thank you. And how about you, Bhargavi?
So for me, it was it was a very interesting journey. I started my career as a teacher. So I was mostly teaching the programming languages, and I was really good at it, and that sort of got me interested into designing the systems. And then I got interested more in the data field, like exploring the different possibilities. I started doing Python was something that I learned and I taught, and that brought me to the field of data analysis. Then I started with data analyst, moved on to data scientist slowly and slowly, and I realized how important it is to have the strong backbone and the ecosystems when actually you're designing a complex model, and then you have to like implement it, so that your insights are continuously generated. I remember joining WeCloudData, and I remember asking, okay, what should I go for? Should I go for data science or data engineering? And I realized how important data engineering is, uh, uh, like when you're working with the data, because it helps you to understand the data actually. So that's how I started my journey with the data engineering. So I started with programming language, SQL, and then slowly moved on to the different technologies.
Cool. Thanks, Bhargavi. Moving on to question 2. What's your day like at, a typical day like at work?
For me, I think it varies, but any typical day I would go into work, I would look at the Jira tickets or the backlog that we have, what we're trying to build, and then figure out what we have to do for the next 2 weeks and just start building that. It also involves a lot of back and forth with other teams, chatting with other teams to make sure we have the right requirements on whatever we are pushing out. It's meeting their requirements, testing it, and then iterating on that. So yeah, I think no day is really same, but the flavor remains exact, is that you're working with people and you're trying to build something interesting.
Thanks. How about Bhargavi?
For me, it generally starts with checking any email messages, checking if there are any requests that needs to be tackled. And then just moving on to see if there are any flows that needs to be run. If there are any data refreshes that needs to be done. There is a lot of interaction with the different teams on what kind of data that needs to be pulled. Is the data accurate? Sometimes there are many segments that are in the data, and then you have to check the accuracy of that. So there are a number of ad hocs as well that needs to be served. Writing code, debugging. This has been a part of my day in my recent job.
Thanks, Bhargavi. Question number 3. What is your understanding of data engineering? And what are the differences, similarities between data engineering and other data roles? And actually, there was a question from the audience, which is similar to this. Explain the difference between data engineer, scientist, and data analysts.
I think there was some content on it that Shahwa shared too. There are differences in maybe the kind of work that you're trying to accomplish. So, as a data engineer role, you're trying to build pipelines that are scalable, that are resilient, that do not break much, and just trying to clean the data, transform it, and bring it to a platform. As a data scientist, your goal might be that you're taking that data and building insights out of it, whether it's reporting, whether it's machine learning models, and making those models available as part of your website, application, part of your processes, something like that. So I think their goal is different. The kind of skills that you might use, there might be some similarity. You might find people working with Python a lot on both sides. There's SQL involved on both sides as well. So there's similarities in terms of skills, but in terms of your end goal, I think your objectives might differ.
Yep, I completely agree with Pratika. The goals may be different, but the skills they may be very same. But like for the DE, like I feel they are the very backbone, of the team, especially when there is a need of the correct and the accurate data, and also they are responsible for making sure that the data is delivered in a timely manner. So making like Kritika said, and like Shawa mentioned in the beginning, making sure that the end-to-end pipelines are working correctly, the systems they are in place. If you're using the different tools, they're working properly together in the sync. So I think they're required for for maintaining, building, the very architecture and the ecosystem that can be utilized by the other teams within the organization.
Thank you. Yeah, my 2 cents on this is that data engineers also tend to work with raw data more, and they probably deal with bigger data set because some data engineers, not always, some data engineers actually will work more closely with the data science team. So they'll prepare data for the data scientists. And data scientists are usually work with more prepared data. Or they can do all kinds of experimentation, but once they want to automate the data pipelines, preparing all the features, it's probably the data engineer who's going to help doing the automation. But be ready to wear multiple hats. It really depends on the companies you're working for. If you work for a relatively smaller startup or a company that has relatively smaller data teams, data team, then sometimes you work as a data engineer, and sometimes you're the data engineer / data analyst or BI developer, because you may need to build dashboard as well, or at least prepare data for that. But it's not that common for a data engineer to build machine learning models. But I do find that a lot of data scientists sometimes need to work more like a data engineer. If in their capacity they need to use Docker, they have to use Airflow to automate machine learning pipelines. In bigger organizations, these are probably separate roles, so you need to be prepared. And the data analysts are more on the analytics side. So they're helping business answer questions like, what happened and why something happened. So you always need to communicate with the business, but not saying that data engineers don't need to communicate with the business, because, there are product managers and, data owners who actually are sometimes from the business side. So data engineers need to work closely with them, because I think I agree with Pritika and Bhargavi, having you need to have the data you prepare needs to make a lot of sense. You need to have the right data architecture as well. Otherwise, the data, if your data is not modeled properly, then it might be really painful for your data analysts to write queries, right? So but yeah, just my 2 cents. Let's move on. Question number 4. What's your opinion on the data engineering job market? I sort of alluded to that at the beginning, but since you work for different companies, maybe you can shed some light on this.
It is pretty strong, honestly, and it's been growing heavily for the last couple of years. There's robust demand in the market. I think there were some stats that were shared initially as well, and compensation-wise too, it's a very competitive job to be in. One other thing that I would say is that a lot of folks, when they try to get started with it, they think that data engineering is kind of like the be-all, end-all, and if you do data engineering, you kind of get very focused on one aspect. Actually, that's not the case. It offers a lot of variety, and you can choose to do something else after this. You can be a data scientist, you can go back to software engineering. So there are a lot of paths that open up. So it's not like it's a very, I think of this role as a very flexible role in terms of what you can do, because it's a mix of software, data, and a lot of other things. I think it involves a bit of managing your projects, managing different types of sources, requirements. So it's a very it's a pretty good role, and sits at the center of what your company and data teams might be trying to do, and there's a growing demand for it. Paragvi, do you want to go next?
That's a great point. Thanks.
Yeah. So what Pratika said, totally, I agree. It's a very growing field, and I would suggest, like, even if you're interested for the data science, but you have some of the good programming skills, and if you're really curious about the data, you can get started with the data engineering. It's really very robust. It's versatile. You can definitely move it from the data engineering to the other fields. But with the data engineering, the thing is that because you will be dealing with the raw data, you will know a lot about how can you handle data, how to prepare it for the desired problem that is being solved. you will know the nuances, like what are the different errors that can happen in the data, what are the different sources from the data is captured. You will also get an idea about the data governance, which is nowadays very it's important. I think companies are focusing now on now more on the data governance, and maybe Shava and Kritika can add to it. So I think it's a very good role profile to get started with. And the job market it's really hot if you have the right skills.
Thank you. I like the answer. Question number 5: how do you know if data engineering is the right career path for myself?
It's interesting, actually. I cannot give a blanket generic answer here that it would be the right path for you. I can give you an idea of what this looks like, and maybe you can decide if it would be the right path, right? So if you're trying to move into something that is um, that has job growth and that has opportunity to expand into other things, and if you enjoy working with data, or have maybe done some data analytics in the past, or maybe have worked with Python or SQL, and you thought, oh, this is interesting, I would love to learn more about it, then this is a career path that's worth exploring. So it's extremely flexible, and if you try it out for a year or two and you don't like it, it's not the end of the world. You can move to something else and it would still be very much relevant. So it's not a fixated path that if you do go down this road, your options would get limited. Actually, looking at the current job market, your options would only expand. And right now, if you look at any job posting, and they don't have to be data related, even folks who hire for strategy or management or operations position, they look for people who have data skills. It's just kind of like how it runs. It's just part of the DNA now. So these are good skills to acquire anyway, and whether it's a right path for you or not, embark upon it, and then I think that would give a good idea of if it was or not. Bhargavi, do you want to go next?
Yeah, so for me, the way I chose this field was like, because I worked on the analysis side, and also I worked as a data scientist. Uh, and like, I was okay presenting the results and everything, to the upper management, to the clients. But I was more interested in managing the systems, creating the new systems like pipelines, or okay, how can I make it more efficient? How can I reduce the time when the data is delivered? How can I maintain and see how accurate the data is? So these things, they actually brought me into this field. So I would say, like, from my point of view, I would say, if you're really interested in designing the systems, if working on the back end, but managing everything, maintaining the systems, I think I think you should go for it. Also programming, if you're very good at programming, writing code, writing the complex code, you have a good command over the different scripting languages, for sure, go for it.
Thanks, both. Question number 6. Do you have any advice for career switchers, people who may not come from data background or engineering background?
If you have decided that this is the path you do want to take, I think investing in building up that knowledge is super helpful, so that can set you apart. Doing some projects that you can showcase your work in, using some common data engineering stack, and just knowing the overall stack, I think, is helpful. And once you have that kind of like a profile set up, some projects under your belt, I think it gets easier to build a case to show that you're interested, and as well as that you actually invested the time to do projects on your own. So I think, yeah, that would be my advice, is that if you've made up your mind, then start building on it, start working towards it, and then once you feel comfortable, you can start applying for jobs. Bhargavi?
Yeah, so I can share the way I did it because I switched it. So I initially started by making a list. So I made a list actually of what is required, what are the skills which is required for the data engineer, what are the skills that I have, and what are the skills that I need to learn. which are the important ones which are currently in the market. I read a lot of job descriptions. I talked to a lot of people. What are the skills that are currently in use in the industry? And then I decided, and then I rated myself. Okay, so like for programming, this is where I stand. For SQL, this is where I stand. And then I started practicing on like learning those skills. So I started Python. I already know. Programming, I already knew. SQL, I had a good hold of. Spark is something where I started because I saw like how widely it is adopted by the organizations. And I started learning by understanding the very foundations, because foundations of any tool or technology, it is very important, I would say, when you're switching to the data engineering. So that is how I, made this transition.
Thanks for the advice. I'm sure there will be more questions related to this in the question Q&A session. So the last two questions, probably this is the last question. Tell us about your teaching experience. So yeah, both Bhargavi and Pritika, they teach the data engineering diploma program, the boot camp. So yeah, I would like them to share their teaching experience dealing with students who are career switchers. So yeah, please go ahead and share some light.
Yeah, I've been teaching this program for the last 6 months or so. So this was my first cohort. It was actually our first cohort for data engineering, and we saw a fabulous group of students that we had the opportunity to work with. It was super fun. I think we worked very hard on creating the content and the curriculum and everything around it. And the one of the things that we learned was that our classes are usually filled up of people from all sorts of backgrounds. So we have career switchers, we have people who have been doing this or something tangible, something relevant for a while. We have people who are coming from data analyst background. We have people who are doing computer science for the first time. So we try to we try to not let our classes sway one way. We try to, if we see in our classes that there are a few group of people only who are speaking, everybody else is kind of in listening mode. We actually actively try to call people out. So that happens a lot in our classes. Our cohorts are relatively smaller, so we are able to focus on everybody, and actually we remember everybody's names. We would call them out and ask them, hey, are you understanding? Does this make sense? And Bhargavi and I actually, we almost collaborate together on a lot of our classes. So we've almost, if we have classes where we think that, no, nobody was speaking today, or today there was a lot of engagement or things, we make note of that. We try to improve on that. We try to go back and say, okay, let's try this today. So I think we evolve a lot with the students that we work with, and it's been very rewarding so far. Especially just a couple of weeks ago, we had a midterm project where everybody has to come together and do projects, and the projects that the students built were fantastic. They literally blew it out of the park, and we were very thrilled that that happened. So it's a pretty rewarding experience. Bhargavi, do you want to go next?
Yeah, so I completely agree. The classes that we try to have, make them really interactive. We sometimes give the little challenges, which like you can solve. You can come up with your own solution, and then you can discuss it. That kind of helps you think in terms of problem solving, because data engineers, you will be solving problems on a daily basis. So clients are going to come to you, okay, so this is what I need, and this is the automation thing that I want to develop, and then you have to come up with your own approach to do it in the most effective way. So we try to incorporate our experience, what we have learned so far from our transition, from our interviews, and we try to incorporate everything into the classes. We want to share this knowledge, but at the same time, like Pratika said, we have students from very different backgrounds. Like some people having really years of experience with software development. They have the background working with the data, whereas some students coming from the computer engineering background or from some other backgrounds. And we have not only taught, but we have learned a lot from these students through the discussions, through the different sessions, through the questions that they ask. And it's been really a very, very, I would say, rewarding experience, like Pratika said. and the projects, what we seen in the midterm, they were amazing. They were really amazing. The projects that the students they have built. Uh, it's a very enjoying experience for both of us, I would say.
All right, thanks, Pritika Bhargavi, for teaching the data engineering program. Yeah, and for answering the questions. So I think we're at the end of the prepared questions. So but very soon we're going to move on to the Q&A sessions in case you have any questions. We've got some really good questions coming in. So I've taken some notes. So please keep sending the questions. So I'm also going to maybe just spend 2 minutes just introducing the data engineering certification program we launched earlier this year. And this is a program targeting, career switchers. So our goal is basically to help, engineers or people who's coming from traditional database and IT background, or data scientist, whoever who wants to switch to data engineering. You don't really need to come from a computer science background. I think to become a data engineer, of course, need to know coding really, really well. So that's one of the prerequisites, but we have a lot of services that we provide to help you catch up on coding. For example, we help practice LeetCode, HackerRank as well. Yeah, so, but I think the most important thing, just, when you're learning data engineering is, learn how to work on projects. I think at the very beginning, if we throw a project to the students, they probably don't know how to get started. I think one of the things we learned, or personally I learned by working with, Pritika Bhargavi and Edwin, is that at the very beginning, we're trying to teach students a lot of different things. And then start to realize that, the most important thing is actually teaching students how to solve problems and how to, be able to independently learn new things quickly in order to get something done. And that is an important skill itself, because it's impossible for us to teach you everything, all 50 different tools. And then the program is probably going to be pretty boring, because you learn so many different things, but you still don't know how to do data engineering. So yeah, but it's pretty hands-on, and we're hoping to keep improving the program and help career switchers to get into data engineering. And of course, new graduates who's from STEM background, who would like to get into data engineering, start your career. All right, so just a little bit more information on what we're going to teach. So on the programming side, we cover Linux, SQL and Python are mainly the prerequisite, but we do have the pre-boot camp where we help students get up to speed. And of course, once you start the program, there are a lot of opportunities to work on SQL and Python challenges. For cloud computing, we cover AWS and Google Cloud. So even though we help the student, prepare for Google Cloud, GCP data engineering certification, but I think the cloud computing, it's impossible. It's a program on its own. So we teach students how to use AWS, for example, EMR, EC2, S3, or maybe Redshift database, basically how to use these services, manage the services to solve problems and build data pipelines, and GCP as well. When we cover data warehouse, we have a pretty big focus on BigQuery as well. So we cover big data with more focus on Apache Spark and NoSQL, of course. We still cover Hadoop and Hive, and MapReduce is an important concept, but in terms of like hands-on practice, we will basically teach more Apache Spark. And we teach both Scala and PySpark. And on the data warehouse side, we cover some of the popular platforms such as Snowflake, BigQuery, and Redshift will mainly be labs. So I think we're already covering too many things. We may actually trim a little bit just to focus on learning one important tool and get really good at it, because if you understand big Snowflake or Redshift, it's not that hard for you to switch to Snowflake, right? ETL, ELT, data ingestion, integration, this is a really important topic. So we spent quite a bit of time on data ingestion, right? Integration, change data management, working with Apache Kafka, and stream data processing using Flink and Apache Beam as well. And data pipeline tool Apache Airflow right now is very hot. So we cover Airflow, and Pritika also covers SBT if you work in a data warehouse environment, a little bit CI/CD concept as well. Yeah, we covered Docker. Docker was actually covered in the third week, I believe, and then we move on to Kubernetes. So in the midterm, actually, one of the tasks is to set up Airflow running on Kubernetes. Not everybody get to work complete that, but some students did implement their entire data pipeline on Kubernetes. That was very impressive. And we also cover the fundamental knowledge of machine learning, data governance, project management for data engineers. So we'll cover things like Jira, Confluence if you're not already familiar with those. So this is the curriculum, and there are a lot of details, but we have very flexible schedule. So this is a part-time program, so it's not a full-time program, but we have two different options. So it's Wednesday evening and Saturday morning. So you can join the classes if you have a full-time job, and we also provide 6 months of career support after graduation. So basically the support is 6 months of learning and 6 months of career service. And WeCloud will be, basically be responsible for building the hiring partnership and make sure students get hired after graduation. And of course, we help them build, really strong data engineering portfolio. Now, if you are right now, unemployed or you're in transition, so we do have a full-time option. So the learning and teaching class schedules will be the same as the part-time students, but Monday to Friday, because you can study full-time, we do have real consulting projects student can start to work on right away. So you will accumulate at least 6 months of work experience in data engineering, and that will make a lot of difference when you do career switching. So I think we are probably the only company, academy in Canada who's offering real client projects. So yeah, I think these are all the questions we've prepared. And let's move on to the Q&A session. There are a lot of great questions already. So I'm just going to share the question list. Just one second. All right, so these are some of the questions, but keep sending them in, or after these questions, feel free to unmute yourself and ask, okay? So I'll start with the first one. So can you explain the difference between, okay, I think we addressed this already, the difference among data engineers, scientists, and analysts. So I'll skip this one. Thank you for the great session. I have a question. Though data engineering is extremely important, as you mentioned, it does not always receive the right amount of credits from stakeholders. How do data engineers get more visibility and get recognized? I think data engineers do get a lot of credits, but yeah, I'll leave this to Pritika and Bhargavi. And I think we have our assistant instructor Zen, who just joined as well. So Zen, if you're feel free to jump in as well.
Hey, hi Zen. So yeah, it's always it does not always receive the right amount of credits from stakeholders. How do data engineers get more visibility and get recognized? I think this is actually changing now. Honestly, I think there is an understanding. I've worked with many teams, and I think they understand the need of having a data engineer now. And there is emphasis also in hiring and training and keeping people, so giving them the right recognition and giving them interesting projects to work with. So I believe this is changing a bit. But yes, in circumstances where let's say if you're working at companies where this is not the case, maybe you're not getting the right visibility or getting recognized. I think just like with any other jobs, there are ways to solve for that. There are ways to work on your things and market your projects such as they get visibility. So just talking more about your projects, collaborating with people, doing projects that are impactful at a broader company-wide scale. These are all common things to do. But in terms of data engineer, I would at least like to think that this is changing, and you definitely do see in the industry that there is a demand also for data engineers, and also there is practices to keep them give them impactful work and keep them happy as part of their jobs. Yeah. Bhargavi, do you want to go next?
Yep. So one of the points, like what Kritika mentioned, I agree to it. But there is a point that I would like to add as well. Like we talk about the data scientist, data analyst, whose primary goal is to go and give the actionable insights from the data. But then for that they need the right amount of the data, and most of the data, the real-time data that we have, it's very messy. It has got a lot of human errors. So if let's say we don't have a data engineer, most of the times the data scientist or the analyst, they will be spending just cleaning the data. Like I would say like 60 to 65% of the time they spend in just cleaning and preparing the data to make it right to run the models. So if we have the data engineers in the team, the data scientists, they can actually focus on what on their actual job goal, and while data engineers taking care of these pipelines, writing all these pipelines, and then taking down like helping the data scientists to work on their part, whereas providing them with the right data and in the timely manner. So I think so this brings in a lot of credibility and the visibility to the data engineers. And I would say Shawa and Zhang, feel free to add to it.
Yeah, so I think so traditionally, I think data engineers, or folks who work on data pipelines and just moving data around, right, essential data around, they usually are grouped under IT. And I start to see more companies having a separate data team, right, because they have chief data officers as well. And so in a lot of companies, data engineers, like some data engineers, or they work directly in the data team, which is part of the business side. So trust me, like there's the IT side, and there's like for startups, there's the dev teams, but they also have the data teams. And I think the data engineers, whoever is on the data teams, are the cool people in the company in those startups. So you're definitely going to get more visibility and recognition.
Yeah, and also because data engineers, they really understand what the data is telling, what are the different data sources from the data is captured, and what kind of data does any data scientist or data analyst need. So they have a really good control over the data within the organization.
Cool. So next question, does the panel expect the Julia programming language to be used in data engineering, science, or machine learning?
I have not worked at all with Julia, honestly. And if I'm hiring for a data engineer, or if I'm just looking at other job profiles that are out here, I haven't come across any that ask for Julia. Maybe I can be mistaken.
I agree. Definitely not for data engineering. Yeah.
Yeah, so it's more around the data science side of things, but not really for data engineering. So yeah, I'm not sure if
I think you
Bhargavi
can
has
probably
seen this.
compare Julia to Python. There is, a community which is growing really fast. On the Julia side, it's used, for statistical learning and machine learning. But I think in terms of popularity, there are many years for it to catch up. Um, Python. So it's kind of hard to say. For a tool like Python to become almost like the #1 most popular language, there are lots of reasons. It's not only the community, but also like the whole ecosystem, right? So you can use Python to work with AWS and Google Cloud API, REST APIs. You can use Python to actually write software, and there's some startups, great products that actually was originally built in Python. I think Instagram still runs Python, and they ran on Django, right? Python can be used for data science, machine learning, and deep learning. So that's probably one of the reasons why it's so popular. Not saying that it's the superior language. Julia became popular. One reason is it's actually performance is better. But for some programming language to win the market, there are many different factors. but haven't really seen Julia in data engineering, space yet. All right. Following up on question 2 about what day at work is like, would you describe the time allocation of your daily work? For example, what percentage of your time is spent on coding, communication, learning new things?
That is a great question. So, what time is spent on coding, communication, and learning new things and others? I would say 50% of my time is spent on coding, honestly, and all the other time is spent on getting requirements and communicating with other stakeholders, making sure I'm doing the right things. Learning new things, that is a core part of my job because data engineering, the fun part about it is that it changes frequently. So you might find interesting ways of solving the same problem in a better manner. So yeah, you do get to learn a lot of new things. So yeah, I think 50% coding, part of it is communication, managing my projects, managing my expectations, and just working with stakeholders. And yeah, I think all of this comes with learning new things, whether it's people, processes, or technology. I think I learn something new every week. Yeah. What about you, Hardevi?
Yeah, learning is continuous for me. So it's like you're learning every time. Every time you have to, work on some problem. You're learning new thing because you have to come up with, some innovative ways. You have to maintain the efficiency. In terms of timings, I would say 50 to 60% of my time it is in coding or working on the automation or some kind of a pipeline, and the other part is spent in the communication, mostly communicating the challenges if there are any issues, communicating with the stakeholders, with the clients, or in the meetings.
Yeah, and it's probably not evenly distributed across the week because sometimes, like when you're doing a data modeling, collecting the requirements, there are a lot of discussions with the engineering team, sometimes with the business. But once you start to implement something, you may find yourself just coding away for 3 days, and then have to do some debugging for the whole day if you couldn't fix the problem. But yeah, overall, I think that's probably 50% of the time you're going to be doing coding. Which is the fun part, right?
Yeah, definitely.
All right, cool. Any suggestions for getting involved in data engineering projects so that we are able to scale up in technologies while also learning how the technologies work together? That's a great question. Yeah.
While learning, okay, let me read it again so I make sure that I answer well. What are they able to scale up in technology while also learning? This is interesting. So I like to think about it and like there are a couple of ways to go about it, right? One is depending on how much time you have and what skills you maybe know or you're comfortable with to start with. So data engineering project can be from wide variety of things. They can be pretty small. They can be things like automating your SQL scripts, having some airflow and just scheduling your SQL, scheduling some of your workflows to run automatically and just programming that. It can also be an end-to-end pipeline that does some streaming analytics and does some aggregation. So there are a variety of projects that you can do. And I think uh, one of my advices would be to start something small and build up on it. So if you're getting started, maybe start something. If you're comfortable with, let's say, SQL or Python, start writing some SQL scripts on some dummy data that you got off the internet and try to automate that. Then try to put some parameters into it. Try to add new tables, new columns to it. Once you get a good hang of that, then try to, okay, the first time you work with dummy data, take the next step on it. Try to work with streaming data that's coming into the same table. See what you would need to do that. Then take one step back. Take one step ahead. Try to build an API on top of it. So somebody's querying your data, how would that be returned? So I think of this as I really like product management, and I like to think of things like in terms of product now. And I think one of the things that when you look into product management, it teaches you is that you don't build the cycle like day one. You start building it in like pieces. So I think about projects in the same way because you want quick wins. You don't want to pick something really massive, and getting wins and keeping momentum would be very hard. pick something that's small and you can build up on it, because you will quickly start getting a hang of it. You will quickly start winning, and that'll give you the momentum to continue building on it. Bhargavi, what do you think?
Yep, I think you have pretty much answered all the points that I wanted to say. But I would say, like, initially when you are working in the, because you're making a switch, career switch, and because it can be sometimes overwhelming. So just start with the skills that you already have. Let's say if you already know Python, start with some scripts, start with some simple automation projects in the Python, and then build onto that. Let's say you have already started learning Airflow, then start a simple, design a simple a flow that is picking up a data from one location, and then it is just putting the data to the other location. So I think is starting simple, and then the small wins, like Pratika mentioned, they are very important to build the confidence, uh, because that will keep you going. And then slowly and steadily you will see, and then don't rush into learning all the tools at once. Start with just one, get some hold, a grip on the tool, and then move on to the next one. See what you feel is important, and then decide like your path, I would say.
I agree 100%. Thank you for the great answers. Next question: if all the data fits in one machine, network node, oh, sorry. I can't see it. Okay. So let me repeat. If all the data fits in on one machine, is that not considered big data? So the people working with data that fits on one machine are not doing data science or data engineering?
There are a couple of things here. So let's say your data does fit into one machine, and then is that not considered big data? So the people who are working with data engineering, they might not be doing data science. Um, I don't think that if you're working with smaller sets of data, you're never doing data science or data engineering. So let's say, and what you consider big data is very relative, right? A big data for a company like Facebook or Instagram would be very different. Instagram is part of Facebook now, but a company like Facebook or Google or some of these Netflix companies, their idea of big data would obviously be very different from, let's say, a startup which is like, let's say, 2 years old. So I think it's about relativity, and big data is um, it's a broad term, and depending on the ecosystem that you're working with, the company that you're working with, their idea of big data would be different. Having said that, if it fits on one machine, it's not like you'll never be applying any data science concepts on it or any data engineering. You might have data that fits your machine, that, let's say, that's like 8 GB worth of data or something. Like you have some sort of, you have a good machine, it's 8 GB worth of data sitting on it or something like that. You can still use some statistics to build something out of it. You can still use that to build a model on it. So you would still be doing data science. Yes, probably it won't be as scalable, but it would still be a very valid data science model. And same for data engineering. You might be doing you might be doing you might be building API on the data that's sitting. You might be cleaning it. You might be changing column names or something. So maybe you're still doing data science and data engineering, but the scope of the work that you're doing might be limited. So I think it's about scope, and not really about these titles. At the end of the day, these are just titles. What matters is the skill. So I think that can still be applied in some way, shape, or form. Bhargavi, what do you think?
Yeah, and then this definition of data science and data engineering, it's very much different. Like some companies, even the job functionalities that they mentioned, they overlap with the software engineer and the data engineer. Some in some companies, the analysis, the data analyst job functionalities, they overlap with what the data scientist is doing. So like the kind of work that you're doing, the skills that you're using, they are more important than the titles. I would say so. Don't get bogged down by this. Like if you're working on a small data, it's not a data science. Yeah, I don't think it's like that.
Yeah, I totally agree. So yeah, so I think you're talking about the big data aspect of the data engineer, but data engineer is more than just big data, right? So there are companies that don't really deal with huge amounts of data, but they actually need to deal with real-time data, for example. So for example, I mentioned that we have a full-time program, so students actually get to work on real-life company projects. So recently we're working with an IoT company. They're in the farming industry. So I personally think it's very interesting. So they collect time series data from sensors deployed to the fields, but the data is not that big. Well, one of the reasons is that they don't have that many sensors yet, but the data comes in real time. They use AWS. The stack is, the technology stack they use is already pretty cutting edge. They use Kinesis. They use like Lambda functions, but everything is on AWS. But the requirement or this help they need is actually they need a lot of real-time data transformation using Lambda functions, for example. But their data is not at a scale where you actually need to consider Spark streaming. So so I think data engineer is about like picking the right tool. Like it's not about picking the most fancy tool, right? Because the cost might be really high, because cost is also really important aspect of data engineering. You have to save cost for sure. Yeah, but this is a good question. Next one. Hi, everyone. I'm working as a SQL developer, transitioning into data engineer. Do data engineers have to do a lot of presentation with clients?
A lot of presentation. I think it depends on the kind of company that you're working with. In my case, it's not true. I think some part involves communication, and there are ways to do that, presentations or docs or anything like that. But I don't think it's part of every job. So it depends on the kind of role that you take up. Bhargavi, what are your thoughts?
For me, I don't think like there are a lot of presentations, but definitely involvement in the meetings. When a new project comes in, so there is a lot of involvement in the meetings with the data scientist, analysts, and then sometimes you have to give your input on how are you going to solve it from the data engineering perspective, like from the system perspective. But in terms of presentations, there are not many.
Yeah, get prepared with a lot of discussion, whiteboarding, especially when you're discussing data models and system data architecture and then things like that. But not necessarily like a presentation to the business side. Yeah, sometimes you do need to sit in those business meetings because some of those requirements are very much related to how you're going to engineer data pipelines. I have been working as a developer for banks in Brazil. However, I really would like to work as a data engineer support. Unfortunately, I'm having a very hard time to find a data engineering post diploma. Any advice? So I think this is asking about a program. So I think you're at the right place. So yeah, so WeCloudData has a data engineering program. You can go to our website and find more information about it. It's a 6 months part-time, like weekend, weekday evening based program. And yeah, you have to complete 2 capstone projects. The full-time student also spent 6 months working on real company projects. So yeah, the students are quite busy. We're going to launch our second cohort actually in 2 weeks. And in the first cohort, we thought that the midterm may take 2 weeks, but ended up like the midterm itself is taking about a month for the student to complete. But the results are quite amazing what the student were able to achieve. How do panel members teach cohorts of classes while having a full-time job at a tech company? How many hours per week are those classes? Bhargavi, you want to answer the question?
Yep. So how many panel members, while having full-time tech? So, okay, so the classes are mostly in the evenings. It's from 6 to 9 on Wednesday, and then on the weekend. So that we can give sufficient time to the students. Like it doesn't interfere with the jobs that we are having or any of the responsibilities that we have from the work point of view. Pritika, you want to add something to it?
Yeah, I don't think we would be able to do it if it was interfering with our
Yeah.
full-time jobs. So it doesn't interfere with that. This is after work, and we have a lot of support. So Bhargavi and I are not the only ones. There are actually there are other instructors too who help us, and that helps us load balance some of these tasks. So yeah.
Yeah. And
Yeah,
then
so we have, yeah, I think for the program, we have 2 instructors and 3 assistant instructors.
yeah.
So there are 5, I count myself as half. So we have five and a half people supporting the program. So yeah, so you're gonna get a lot of support. So Wednesday evening, 3 hours of lecture. Saturday morning, 3 hours of lecture. Saturday afternoon will be TA hours. So you work on labs and challenges.
Yeah.
And weekday evenings, every night, we have office hours, so you can hop on Zoom anytime if you have questions, you need support, because I think most of the time students will get stuck on something and they will get TA's one-on-one support. So yeah. All right, what's the tech stack you mostly use on a day-to-day basis? I like this question.
So for me, in my recent job, it's mostly Tableau, Python, AWS. It is what we have started to work on. Before it was mostly the Python and the SQL Server that I used. Kritika?
For me, it's Python, SQL, Java, um, Beam, Apache Beam, sometimes Spark, and Google Cloud Platform. So yeah, those would be the main ones.
Yeah.
Right. So yeah, even though we cover a lot of different tools, because from a teaching perspective, we want to cover as many, different aspects of data engineering. But when you actually start to work for a company, you're not necessarily going to use 20 different tools on one project. So yeah, and even though the job postings are going to ask for a lot of different things, usually they will have a few key skills they are looking for. You can always learn new things on the fly as well, right, when you're on the job. Next question, do data engineers deal with the business? I think this has been addressed, or are they separated from the business by, yeah, I think we've addressed this question. So in the interest of time, we will move on to the next one. Why should I study data engineering, not data analytics or data science? Can you explain?
One point that I could think of, definitely if your interest, it is dependent on your interest. Like if you're really interested, I mentioned before as well, in digging deeper into how the systems are managed. If you're very much interested in understanding the data, because even for the data scientist or the data analyst, it's very important to know how to read the data, like what the data is telling, because data is actually a representation of the real world. And if you're really curious about data, if you're in an industry and you want to know what is the actual data, how to actually prepare it, clean it. If you're really curious about it, I would say data engineering is the field that you should start with. And then once you know how it is all done, maybe if you're more interested now in moving to the insights and the analytics part, you can move on to the data science or analytics. But it's also dependent on it also depends on your interest, what like what are you most interested in learning, and the skill sets that you have right now, which makes a career transition easy. Shawa, Kritika?
Um, yeah, I think why should I don't, it's not like I prefer one over the other, honestly. So I would not push you to choose one versus the other. I think I would encourage you to tap into what you think you're interested in and then start from there. None of these paths are absolute, that if you go in these paths, you cannot shift or change around. These are very closely related fields. So yeah, just pick something that you think you like and stick to it, see if it works out for you, and then go from there.
Yeah, as Pratika said earlier, I've seen a lot of data engineers switching to data science and vice versa. And of course, if you're a data analyst, data science might be a natural path for you to go down. But end of the day, I think, yeah, if you're at the very beginning of the journey, just try to learn a little bit more. Just try to learn a little bit data analytics, Python, SQL, some of the, because, for example, Python, SQL are all three different roles need to know these well. So you may want to decide if the data profession is what you want to is the right fit for you. So take a few courses, even just online courses, and see if that's something you're interested in. And obviously, we need to do some research and watch more. I think we will have a formal introduction to data engineering information session next week. So stay tuned. We're going to share a lot more about data engineering and comparing that to data science and analytics, but definitely not, suggesting that you should only learn data engineering. It depends on if that's the right fit. Yeah. So data engineers sometimes, just to elaborate on that a little bit more, sometimes data engineers will help data scientists optimize data pipelines and improve the efficiency of their code. In some cases, right? But if you like to optimize things and you feel pretty proud of that, you feel satisfied, then data engineering should be a pretty cool job for you. But if you enjoy communicating with the business side, work on you like math, statistics, maybe you can consider data science. And if you like visualization, and communicating with the business, maybe data analytics. But this is very narrow definition of these roles, because as I said, sometimes it will be great if you have both data science and data engineering skills, but you don't necessarily have to work as a data engineer, right? Will the data engineering program cover both batch and stream processing? Yeah, we cover both batch processing and stream processing. Stream processing, so I think Pritika will cover the Apache Beam and Spark streaming side, but we spent a lot of time, of course, on batch data processing using Apache Spark, and of course, a lot of batch processing are done in databases. So we cover both SQL and NoSQL, and of course, relational databases are more for analytics purpose. But the answer is yes. Will the program also leverage IaaS, infrastructure as service, like Terraform? I'll leave this to the instructors.
So we do cover part of it, but that wouldn't be our key focus. But we do cover part of it to make sure that if you have to set up something in Terraform, whether it's setting up a cloud project or setting up some data sets or something, we would cover the basics of it. Yep.
Yeah, I remember in the midterm, one of the students actually used Terraform for the project to set up infrastructure. I've also seen another project, a student leveraged CloudFormation in AWS to set up the infrastructure. We cover some of these concepts, and actually Pratika had a pretty interesting AMA session, Ask Me Anything session, and some students actually did ask the Terraform questions. And yeah, but it's more DevOps, but sometimes in your project you may actually need to use it, but it's not the primary focus of the course. What does the career trajectory look like for data engineers? I know there's senior staff levels for data scientists. Do data engineers have similar seniority levels? How do the responsibilities change as you grow? This is also a good question. I think the first question got addressed, the career path. But Pritika, you have any insights on the seniority level, responsibilities?
Yeah, I think the levels really depend on the kind of companies that you end up working with. But yeah, these are the common levels that apply industry-wide. In terms of how the responsibility changes, like when any other with any other company, any other post, right? You would start with something where you'd have support from your team, and then you would quickly start owning some things that are a bit maybe less complex, but they are still owned by you end to end. Then you would eventually start owning things that are more complex and again owned by you end to end. Then again, as a next step, you'll probably have people reporting to you, or you'll have teams that you lead working on something together. So I think the responsibility keeps increasing, as well as the ownership of things increase. And at some point, you might have people that you're leading and mentoring. So that changes with the role.
Thank you, Pritika. Next question, are we going to be taught object-oriented programming or procedural Python? Bhargavi, you want to answer this question? I think you prepared all the Scala tutorials.
Yeah, so Python as such, it is not taught as a part of the course, but as a part of the pre-training for the data engineering. We do release some sessions on the Python. The object-oriented programming sessions, we cover some of the concepts when we are discussing the Scala programming. But they are not dedicated like Python or the object-oriented programming sessions. But then in the office hours, like students can always come in, and if they're having some issues with, or if they want to understand some concepts, we can always go through them in the office hours.
You run into some of the OOP stuff when you actually start to work on the tutorials and labs. So for example, I think when we covered Docker, one of the labs prepared by Zen or Bhargavi, I forgot, but it's teaching you how to use Flask. So you need to know OOP for that. I think there's another lab that we're going to go through, which is, how to collect data how to work with REST APIs and how to, for example, work with, streaming data, for example, using Twitter API. So you need to write a libvirt class as well. And I think Pritika also covered, unit testing, right? How to test your code and pipeline. So using PyTest. So yeah.
And then some of the sessions we did in the office hours as well on the OOP concepts.
All right, cool. Next question, do data scientists typically have a PhD? Maybe I can address this question. So we did some data analysis on the education level for different roles. I would say for data scientists, about 30 to 35% of the job postings will mention PhD. So that means like 60 to 70% of the data scientist jobs wouldn't require PhD. But even when those job postings mention PhD, it's not a must-have, right? Unless it's like, advanced analytics, like things like, deep learning research. But those research-oriented roles usually prefer PhDs for sure. Yeah, so, and even less so for data engineers and data analysts. If you have a PhD, you might actually, some companies will consider you as overqualifying for a data analyst role. So yeah. You definitely don't need a PhD to become a data engineer. So, for Apache Spark, does the program emphasize more on PySpark or Scala? Which language is more relevant in the job market?
So for Apache Spark, the project that we have built, we teach Scala, and then the projects are being done and covered in both the PySpark and the Scala. In terms of the language, I think Scala is picking up the pace. A lot of companies are now looking up for the Scala developers, and also the salary is very competitive if you know the Scala.
Yeah, yeah. So we teach both Scala based Spark and PySpark. I think there are more labs in PySpark, but I think Edwin covered Scala Spark mainly based on Scala. In the job market, it depends on the companies you're going to join. There are some companies, the data engineers need to work more like a software developer or engineer, and they work in IT. So I think Java or Scala might be preferred. Those companies also have stronger, engineering culture. But I've also worked with analytics companies or consulting companies. When they build a data engineering team, they just go with PySpark. That's mainly because there are more folks familiar with Python in that organization. Just like R and Python for data science, there are more teams using Python for sure, like scikit-learn and pandas. But there are also teams that because most of the employees or data scientists are coming from R background, then they would prefer R. But I think when it comes, yeah, so that's just my 2 cents. There's one more question from Dave. What programming tasks does a data engineer do in Java?
I can take that. I think there are a lot of things that you can do in Java, especially when it comes to writing some of these ETL pipelines, whether it's Spark or Apache Beam or something. So yeah, I think there are use cases for Java also in the data engineering stack, especially when it comes to writing streaming pipelines or larger batch data pipelines.
Yeah. And if you work for banks, they have their enterprise, whatever, tools that usually Java, like on the back end, they usually use Java. Java will be preferred. Depends on the company, I think. And if I think Java also, it was quite popular when it comes to like writing Hadoop MapReduce jobs. And of course, you can do that in Spark using Scala, but we can do that in Java as well. Yeah, it depends on the company, I think, and data engineering team. Okay, it looks like we get to all the questions here. There's one more from Chris. How important is knowledge of web frameworks like Flask and Django for data engineers? I can take this one, and maybe Pritika and Bhargavi, you guys can comment as well. So I don't think it's that important, but knowing web framework and how to work with REST and microservices, I think these are important concepts to know. We don't teach Flask or Django in in this program, but there's actually labs related to that. One use case I can give you is that in a real company project that our students worked on actually in the past few weeks is for a sports analytics company. And so basically we're doing data engineering for them, setting up data ingestion. So and the data is, so first of all, they read data using Python or using PHP API from sports API. But they would like to leverage the real-time push feeds, right? Push events. And so basically, and some APIs provide like, webhooks as well. So you probably need to have an endpoint yourself to receive data and send the data to a database or a data lake somewhere. So in that case, we just use Flask to implement the push API. So the company, because they can read data directly from the sports API, but right now it's COVID period, so some games are not really on. So they are working with so we built a simulation API for them, so that they can keep testing their machine learning and whatever model prediction pipelines. So that's one use case, is to use that. Or if you want to implement webhooks, you can use Flask as well. As a data scientist or ML engineers, sometimes machine learning models can be deployed using Flask. You can build endpoints, even though it may not be that scalable. But building something quick and dirty using Flask is definitely easy to get started. Or you can look into Fast API that supports async much better than Flask. Seems to be getting trendy. But Django is for building websites and web apps. It's pretty heavyweight. I know Instagram and some companies are built using Django. Yeah. Are there any other questions? Cool. So we have one more data engineering info session, I think next week. If you're interested in learning more about our program and data engineering and job market, you can come to that session. We also have some data engineering related meetup events, I think in the coming months. So stay tuned. And I would like to thank Pritika and Bhargavi very much for taking the time to answer some of the questions here. And thanks for being so engaged, all the audience. So I look forward to seeing you guys in the near future. Thanks, everyone.
Thank you, everyone.